The Pythagorean Theorem is one of the most classic pieces of geometry that you're going to learn this year. And whenever you hear the Pythagorean Theorem, it literally is this right here. A squared plus b squared equals c squared. When we're looking only at a right triangle, where c is always the hypotenuse. And that is the most important idea here. C is always the hypotenuse, and you'll always know that because it's across from the right angle. And if you notice here, the right angle kind of points over to the hypotenuse. The hypotenuse is always across from the right angle. So that's the most important part of the Pythagorean theorem as we go over here. So I notice I have a right triangle, and I know that it points to my C, the hypotenuse. The other two sides will automatically be A and B. It does not matter which side is A and which side is B. The only thing that truly matters is that you labeled your hypotenuse as C, and now we can set it up. A squared, so instead of A, I'm going to put 12 squared, plus B squared, in this case that's the 5, equals my C squared, which I don't know in this problem. That acts as X. And now I have my setup. A squared plus B squared equals C squared. Now in order to solve this, whatever numbers we know, we're going to go and actually square them. 12 squared means 12 times 12, which is 144. 5 squared means 5 times 5, which is 25. And we don't know the number for x squared yet. And now we'll add these up since they're already on the same side. 144 plus 25 is 169. We still haven't touched that x squared yet. Now here we are. Now we have to get rid of this exponent of a 2x squared. And this is where you need a new inverse operation. Exponents and roots are inverse operations, which means they are opposites and they undo each other. So if you need to get rid of an exponent, we're going to use a root. And since this is x squared, we're going to use the square root, which looks like the check with a box on top. The check with the box on top. And like I said, those undo each other, so we're left with just x. And when you take a square root, we ask ourselves, what number times itself gets us back to 169? And if you guys are struggling to think of that number, you can always on your calculator hit second, x squared, and you get your square root button. And this problem will come out to a nice even whole number of 13. X equals 13 then. So let's try this again. So here's a nice right triangle with a missing side. The most important thing is to find your right angle and see where it is pointing, because that is our hypotenuse, which is always our C. This is always going to point over to that hypotenuse so we can get C. The other sides are automatically going to be A and B. It does not matter which one is A and which one is B. All that matters is that you found the hypotenuse and labeled it as C, because that is what needs to be alone when you set up your problem. So now we'll do A squared plus B squared equals C squared. So instead of A, I'm going to use the number I know, 9 squared, plus B squared. In this case, that's X, so I don't know it. So that'll be plus X squared equals whatever my hypotenuse is, C. In this case, I know it, 15 squared. So that's the only difference between the first example and this one. Last problem, we didn't know the hypotenuse. This time, we're missing a leg of the triangle instead. The solving will be very similar, just with one little step in between. We're still going to go take the numbers we know and square them. 9 squared is 9 times 9. We don't know what x is to square it. And now we'll go do 15 squared. 15 times 15 is 225. Now before we can deal with our x squared, that exponent, we need to get x squared alone. So I need to take 81 and move it to the other side. And I need to use my inverse operation since I'm going to the other side of the equal mark. So if you notice, last time we just added, this time we have to subtract. So we'll end up with x squared is equal to 144. we're left with just the exponent. Roots are the inverse operation for the exponent. So x squared, I'll do a square root. Those undo themselves. And what number times itself will give us 144? 12 times 12 gives us 144. So we know that missing part is 12. Let's try out one more. So let's solve for that missing side. So I find my right angle and I know it's going to point over to my hypotenuse, which is always C. The other sides will be A and B. Doesn't matter which ones you label. All that matters is that your hypotenuse is C, because that's what needs to be equal and alone, equal 17 squared. And now I'll go grab my A, x squared plus B, 10 squared. And now we're once again ready to solve this out. So in order to solve this, we're going to take the numbers that we do know and square them. So 10 squared is 10 times 10. 17 squared is 17 times 17, which comes out to 289. Now before I can deal with my x squared and get rid of the exponent, it has to be alone. So we have to get rid of this 100. We'll subtract it. We end up with x squared is equal to 189. In order to get rid of your exponent, the inverse operation is the root. So I'm going to do a square root for x squared, and that's going to get rid of my x there. So now I'm left with the square root of 189. If I go to my calculator though, and you do the square root of 189, you get a crazy ass decimal. And from now on in advanced math, we don't want that final answer as your answer. If you don't get a perfect whole number, if this number is not a perfect square root, then you have to reduce the radical like day one taught you. So in order to reduce the radical, we need to fully factor this. And if you don't know how to multiply to 189, go to your calculator. Do 189 divided by 2, see if you get whole numbers. Do 189 divided by 3, see if you get whole numbers. 189 divided by 4, divided by 5. Keep testing different numbers until you get an option that works perfect. So when I went to my calculator and I did 189 divided by 3, I got 63 as a perfect nice whole number. So I know that 3 times 63 gets me back to 189. And then when I experimented with 63, when I divided 63 by 3, I got 21 as a nice answer. Then I know that 21 is 3 times 7, and I can't break that down anymore. So if you remember our reducing radicals, if I broke a number down, I'm going to cross it out. If I broke a number down, I'm going to cross it out. As now it's time to circle up the pairs. So I see a pair of 3s here, but I don't see another 3 for this guy, and I don't see a partner in crime for number 7. So I know that left in radical jail is that 3 and 7, because they don't have any other factors to pair up with. They don't have any partners in crime. So then over here I have El Chapo escapes, his helper doesn't make it. And now if I'm left with two numbers, I multiply them. So x will equal 3 on the square root of 21.